Okay, to introduce the concept of open sets, we have to investigate the relations between point and the subset, and we discuss when a point is called an interlinear point of a subset. The relations between point and the subset has the other situation. This is what we want to discuss now. We have a definition. Suppose S is a subset of Rn and A is a point in Rn, not necessarily in S. Let's draw a picture. This is S. So if the point A lies here, then this A is an interlinear point of S. But A can also be here, outside of S. Even A is not in S, the point near A is also not in S. Okay, this is a situation we will discuss now. And also we have this case, that is A lies intuitively lies on the boundary of S. We will also discuss this case. Firstly, in this case, we say that A is an exterior point of S. If there is the epsilon positive, such that the epsilon neighborhood of A has empty intersection of S, which S, then A is called exterior point of S. Okay, this is the first case. So following this condition, what this means? This means the epsilon neighborhood of A contains in the complement of S. Therefore, A is interlinear point of the complement of S. So this is the first case. The second case is that A lies on the boundary. Okay, so how to express this? A lies in the boundary of S. So intuitively we see that for any epsilon positive, the epsilon neighborhood of A contains points in S and also contains points outside of S. Therefore, this is the case. So this motivates the following definition. If for any epsilon positive, the epsilon neighborhood of A has no empty intersection of S, which S, and also this epsilon neighborhood also has no empty intersection with the complement of S. That is to say, any point, any epsilon neighborhood of A contains points in S and also contains points not in S. In this case, A is a boundary. A is called a boundary point. Of S. Boundary is important for us. So we consider the case that we consider the set consists of all boundary points. So the boundary of S, all boundary point of S consists of a new subset of Rn. Denoted by ds, or sometimes denoted by ext exterior as bds, boundary, which is called the boundary of S. Okay, so we have exterior points, boundary points, and the boundary. Of course, we can also consider the set consists of all exterior points of S. That is called exterior of S. Using this notation, but we will not use exterior S very often. Therefore, we don't discuss this here. Now we have a closer look at the boundary. From the definition of a boundary point, it is clear that remark if A is a boundary point of S, then A is also the boundary point of the complement of S. Because these two conditions defining the boundary point is symmetric. Replace S with the complement of S, this condition remained unchanged. Right? In the definition of boundary point, you replace S by the complement of S, because the complement of the complement of S is exactly S itself. Therefore, in the definition, we replace S with the complement of S. The definition is the same. Therefore, A is a boundary point of S if and only if A is a boundary point of the complement of S. Consequently, the set S and its complement has the same boundary. This is very important, and we will use this later. Okay, this is an important fact. Okay. Now, having defined the exterior point and the boundary point, exterior and the boundary, we will give you a simple example. So, this is an example. Suppose S is the ball, center and origin, which radius R. So what's the exterior of S and the boundary of S? So the exterior of S is those points in Rn whose norm is greater than R. And the boundary of S is all points in Rn whose norm is equals to R. We draw a picture to have an intuitive impression of this. S is the ball, radius R, so S is this ball. The boundary is not in S. The circle, the sphere is not in S. So the exterior of S is this part, and the boundary is this circle. Represent the boundary of S. Okay. So of course we need to prove this result. The proof is not difficult. Of course, this is the equality between two sets. These are equality between two pairs of sets. So we need to prove, for each equality, we need to prove one side is the other subset of the other side. We consider the exterior of S first. Suppose a point A belongs to the exterior of S, then there is an epsilon positive such that the epsilon neighborhood of A intersect S become an empty set. So A is here. The epsilon neighborhood of A, the intersection of this epsilon neighborhood of A, which the S is empty. Okay. So we see that the norm of A, no, fully. Now we will give examples of the exterior and the boundary of a given subset of Rn. Example. We consider S is BR, the ball center and origin which radius R. Then, what's the exterior point and the boundary of S? It turns out that the exterior of S is the set consists of X in Rn whose norm is greater than R. And the boundary of S consists of X in Rn whose norm is exactly R. So this boundary of S, because it consists of all points having distance R to the origin. So this is a sphere, center and origin, and which radius R. So it has a special name. Sphere, center and origin, radius R. Okay. So if we draw a picture of this, it will be very clear. So here is our S. Here is our S. So the point here is an outside of S, and the point near this A is also outside of S. So it should be an exterior point. On the other hand, any side on this circle should be the boundary point of S. Let's prove this conclusion. These two equality are equality between two pairs of subsets in Rn. So to prove each one of this equality, we need to show that one side of the equality is a subset of the other side. For example, we consider the exterior of S. Consider this case. Our first step is to prove this direction. Okay, so take A belongs to the right hand side, which means that the norm of A is greater than R. So what should we do? We want to find epsilon positive such that the epsilon neighborhood of A has empty intersection with S. How to determine this epsilon? How to determine this epsilon we want?